Hi, so welcome to another video, and in this one we are going to discuss computing confidence intervals of population mean using these statistics. So first of all, let us figure out what confidence coefficient stands for and what confidence interval means. So the confidence coefficient is the probability that a randomly selected confidence interval contains the population parameter or population mean. So the relative frequency with which similarly constructed intervals enclose the population parameter when the estimator is used repeatedly a very large number of times. And confidence level stands for confidence coefficient expressed as percentage. So when we compute confidence interval, we want to figure out the minimum and the maximum possible value for population mean with different degree of certainty expressed using confidence coefficient. So on this slide, you can find the formula for computing confidence intervals. So when we know population standard deviation, we use it. When we do not know population standard deviation, we use sample standard deviation. X bar, as you remember, stands for sample mean, and N stands for the number of observations. When it comes to Z, it is just some constant value. We can extract it from the table, and in a minute I will get back to this. Okay, so we can compute confidence interval by subtracting this value from the mean and adding this value to the mean. As the result, we will get the lower and the upper boundary. And it can only work under two conditions. First, random sample should be selected from the target population. That's why sampling is so important, as we discussed during the second lecture. And second, the sample should be large enough, which means that there should be at least 30 observations. However, when it comes to the size of the sample, you can take a look at the formula once again. So basically, when constructing this part, we have to multiply z value by the value of standard deviation and divide the obtained result by the square root of number of observations. So basically, you can easily figure out that when you use larger number of observations, as the result you get smaller spread for your confidence interval. So the difference between minimum and maximum value for computed confidence interval will be smaller if you use bigger number of observations. Okay, so there are several commonly used confidence levels. 90% certainty, 95% certainty, 98% certainty, and 99% certainty. And the corresponding value of alpha is simply 1, because probability is equal to 1, minus the corresponding confidence coefficient. Here, we are going to discuss standardized normal distribution, and as you remember, it's symmetrical and the value of mean is 0. So when you estimate the interval, the confidence interval for the population mean, then you will look both to the left and to the right hand side of the distribution. So that's why we divide alpha by 2. And those are the corresponding values of Z. Again, you just use them, you do not have to compute them. I just wanted to explain you how to use this table. So perhaps it's not that clear, that's why let's try to discuss everything based on some example. So as a sales manager, you're responsible for making sure that there are enough inventories in the stock. At the same time, excessive stock means losses for your business. So it's a kind of a waste of money for you. So you want to estimate the approximate number of units of some good you have to order in order not to be in short and not to keep excessive inventories as well. So during the last 111 weeks, you collected the sales data. On average, consumers purchased 120 units of good A per week, and standard deviation is equal to 14 units. And you want to be 99% sure that you will order just enough units of good A for the next week. And the question is how many units you should order. So in order to solve this problem, we can use the same formula as discussed before. So here mean is equal to 120, there is 111 observations, and standard deviation is equal to 14. So we know that for 99% certainty, this is the corresponding value of Z. So you simply put all those numbers to the formula, and this is the result. So we know that the mean will be contained within the boundaries described by this equation. So basically it's 120 minus 3.42 and 120 plus 3.42. That's it, as simple as it is. So in the next video, we are going to discuss how to compute confidence intervals of population mean using statistics. As for now, that's it, and thank you for watching.